All right, so acceleration on ramps. You can see I already worked through these, but I hadn't made a video for it, so I'll try to do that. If you have a box that's on a ramp, we've got the force of gravity pulling us straight down, and that force of gravity gets split up into two components. One component that is parallel with the ramp, and it often is just described as down the ramp. So this part is parallel with the ramp, and then this part, which is perpendicular to the ramp. This portion will end up being mg cosine of theta, while the down the ramp portion will be mg sine theta. Now this is what's pulling me down the ramp. So since it says there's no friction, this is the only force moving me forward. So my net force is equal to ma. So mg sine theta equals ma, and so my acceleration is just g sine theta. As theta increases, what it's saying is the ramp is getting steeper and steeper. Well, originally you have no component of gravity pulling me down the ramp because the ramp is just flat. But then as it becomes a small increase, that sine theta portion becomes small, and then it gets a little bit bigger, and then it gets to the point where most of the force of gravity is parallel with the ramp as you get steeper and steeper. So the parallel component of gravity will increase. Compute mg's sine 25. You just do it. There's really not a whole lot to that. 6 times 9.8 times sine of 25. A block stays at rest on a ramp. The maximum static friction, I remember. Yeah, I just didn't like how this was worded. The maximum static friction would have to be greater than mg sine theta. But if it were just sitting on the ramp, it would be equal to mg sine theta, because while friction has the ability to be bigger or smaller, in order to actually make it stay at rest, the force of friction needs to be the same size. I think equal is really our answer there. On a frictionless ramp, what component accelerates the block? So that's the same thing as up here, the mg sine theta portion. All right.